Hey, welcome to a new episode of Technically Speaking. This episode was inspired by, as usual, a conversation that Mark and I had about something that was completely not related to the computer industry. I recently purchased a new turntable, and the turntable platter, it happened to be made out of ceramic. And the ceramic was very carefully machined to be very thin in the middle and have most of the mass near the edge. And that, of course, led to a discussion about something that Mark is much more knowledgeable than I am about, which are kinetic batteries that use ceramics to produce and smooth out power. Now, this is an area that I know a little bit about because modern data centers have two problems. One is that they need to have smooth power or regulated power that's not subject to perturbations from the electrical grid. And the second benefit is that they produce a big power reserve. So if the electrical grid goes down, then they can be used to drive it. So Mark, tell me what you know about this stuff, because it blew me away.
This is one of these wacky technologies that moves the border out a little bit. But in essence, what we've got here with these kinetic batteries, their official name is Flywheel Energy Storage Systems, FESS. But what you've got here is you've got power coming in, it turns a flywheel. The flywheel also powers a generator, which produces electricity and moves it out. Now you may say, why the heck did we go through that power through a bunch of mechanical things to generate power? Well, the reason is exactly what you mentioned, Ned. If we have fluctuations in the power, the inertia of that flywheel is going to even those out. It's going to dampen it. And in fact, if we lose the power, that flywheel is going to keep generating electricity. So if you have a short outage, the kinetic battery will actually keep producing power. Life is good. Power comes back on, generates the flywheel. Now, let me tell you, these things are built, because this is where I think it gets super, super cool. When I'm talking about these flywheels are spinning, I'm not talking about RPMs. I'm talking about hundreds of thousands of RPMs. These flywheels get spinning so fast that regular crystalline metals will be pulled apart by the centrifugal force of this. And these flywheels may be measured in tons. There's actually a research lab out there that has a pair of 70-ton flywheels. If this flywheel flies apart, we are talking about tons of TNT of explosive power. So they're encased in this housing that is packed with this gelatinous liquid. I think of it as jello. It's probably not actually raspberry jello, but imagine that it is. Right? The idea is this thing blows apart. The kinetic energy of the parts flying out will hit this, go through a transition of changing it from a solid to a liquid and a liquid to a gas, and contain all of the energy from the explosion, right? So yes, under your data center may be a small little swimming pool of jello.
So one thing that you brought up, Mark, which is the power grids, we think about the wall power as being very regular. But the fact is that the power grids are shared across millions of different people with all their different use cases. So inside of your house, for example, when your refrigerator condenser turns on, it causes a brief spike or a brief dip in the power that's available to the other things inside of your environment. Same thing in data centers. And the other thing that you described to me when you first told me about the jello coating, where we need to have the energy dissipated from solid to liquid to steam. And by the time they're done with that, you've got either a pool of slag on the ground or a jello mess. Hopefully it's not cherry jello.
Yeah, I mean, ultimately, you don't want your flywheel to fly apart. However, for safety reasons, you have to kind of be prepared for that.